is Sai. Today we are going to solve some problems in motion, and we are going to do simple idea of circular motion. This is not one of the part of fundamentals of motion. You know, we've divided fundamentals of motion into part 1, part 2, part 3, and part 4. This is not one of the parts, but this is not just an addition to it. Okay, before we move on to today's topic, let us go back to our last tutorial and clarify a question that we did there. Okay, the question said that a man walks 10 meters east and 10 meters northwards. Find his displacement and direction. So the question, these are the 4 cardinal points: north, the south, the east, and the west. The question was saying that if a man walks 10 meters east, it means that this man was walking 10 meters due east and 10 meters northwards. 10 meters northwards. Said find his displacement and direction. So as I told you in our previous tutorials, that this will be his displacement. Let's call it x, and let's call it angle alpha and angle theta. So from here we can see that the formula to find this is s squared is equals to 10 squared plus 10√3 squared. Then we have that x is equals to the square root of 10 squared plus 10√3 squared. Now we can now see that x is equals to 10 squared is 100 plus 10√3 squared is 300. Check it in your calculator. 10√3 squared is 300. Then from here we see that x is equals to root 400, and root 400 is 20. It means that x is 20 meters. It means that this is his displacement. This is displacement. This is the displacement of the man. So now to find the direction of this man on this plane, now this is how it's moving. This is P. So now to find the direction of P on this plane, which is the direction in which the man is moving, we are going to find angle theta. But to find angle theta, the first thing we are going to do is to find angle alpha. Now what is angle alpha? From our trigonometry, we know that tan alpha will be opposite over adjacent. Now tan alpha now will be opposite. The opposite angle to the opposite side to alpha is 10√3. So it's 10√3 over the adjacent side to alpha is 10 meter. So now when 10 cancel 10, we are going to have tan alpha to be √3 meters. That means that alpha is equals to the tan inverse of alpha. That is the tan inverse of √3, and the tan inverse of √3 is 60 degree. That means that angle alpha here is 60 degree. Now to find angle theta, we know that this is an angle of 90 degree. This is an angle of 90 degree. So to find angle theta, angle theta will be 90 degree minus alpha. So you know that alpha here is 60 degrees, so theta is now 90 degree minus 60 degree, which is equals to 30 degree. It means that theta here is 30 degrees. Now from what I taught you earlier, how to find the direction, we know that this man is moving north 30 degrees east. North 30 degrees east. That is his direction, this is his displacement, and this is his direction. So that is it. That is what I wanted to clarify on the last tutorial before we move into the fresh topic. Now let us solve a problem, an additional problem on the equations of motion before we move to circular motions. Equations says that a train slows from 108 km per hour with a uniform retardation. Note this word, retardation, of 5 meters per second. How long will it take to reach 18 km per hour? And what is the distance covered? A train slows from 108 km per hour. So it means that the initial velocity of the train is 108 km per hour with a uniform retardation. Retardation is the opposite of acceleration. Retardation is negative acceleration. So it means that the retardation, you can call it acceleration, that is a negative acceleration, is equals to minus, you see here is 5 meters per second, but I'm putting minus because of retardation. It's negative acceleration, minus 5 meters per second. How long will it take to reach 18 km? So they say the final velocity is 18 km per hour. So you are asked to find t, how long, which is the time, the t, and what is the distance covered, and the s. So that those are the variables you are asked to find, the time and the distance covered. So now, how do I go about this? The first thing I'm going to ask myself is, look at these units. They are not the same. This is meter per second, this is kilometer per hour. So what do you do? The first thing you do is to convert this from kilometer per hour to meter per second. And how do you do that? How to convert from kilometer per hour to meter per second? You do that 108 times 100 over 60 times 60. That's how to convert this from kilometer per hour to meter per second. 60 seconds make 1 minute, 60 minutes to make 1 hour. So that's how to do it. Then this is 1000 times 1000. So this is going to give you 30 meters per second. When you do this with your calculators, check it out. It's going to give you 30 meters per second. Now I've been able to convert this from kilometer per hour to meter per second. So now the next thing I'm going to do, look at this again. This is also in kilometer per hour. So I also convert it to meter per second. So convert this, that is 18 times 1000 over 60 times 60. That will give you 5 meters per second. Check it in your calculator. That is the answer. So now we go on to solve the equation. Now I've gotten the units are now uniform. I can now solve. So from there, what equation do I use? I need to find t. Let's go to the first equation of motion. The first equation of motion says v is equals to u plus at. That's the first equation of motion. So you can see that v here, the final velocity, which is v, is 5 meters per second. The initial velocity is 30 meters per second, plus the acceleration is negative 5 t. So that means that 5 is equals to 30 minus 5, plus minus is minus 5 t. So that will give you that 30 minus 5, or let's say this goes to me, so it's give you 5 minus 30 is equals to minus 5t. This will now give you minus 25 is equals to minus 5t, and that will give you t to be equals to minus 25 over minus 5, which is equals to positive 5 seconds. 5 seconds. So the time it takes is 5 seconds. So now the next thing you are going to do now is to find what is its distance, to find the distance, which is x. And what equation of motion do you use? So I don't know which one to clean. I'll go with this. So you are asked to find the distance. So now from here I can use this equation of motion. V squared is equals to u squared plus 2as. Now the v squared, the final velocity is 5 meters. So I have this 5 squared is equals to the initial velocity is 30 plus 2 times acceleration minus 5 times s, which is what I'm looking for, which is the distance I'm looking for. So now here we know that 5 squared is 25 is equals to 30 squared is 900 plus this is 2 times minus 5, that is minus 10s. So that will give you 25 is equals to 900 minus plus minus is minus 10s. So from here now, what do? This crosses over here. You have that 25 minus 900 is equals to minus 10s. That will give you 25 minus 900 is 875. That will give you minus 875 equals to minus 10s. Now you now have that to get your s, which is your distance. S is equals to minus 875 divided by minus 10, which will give you the answer to be 87.5 meters. So that is it. It means your time is 5 seconds and your distance is 87.5 meters. That is the joy of equations of motion. You can solve some problems with it easily. Now let's move on now to the single idea of circular motion, which is our main topic for today. Okay, now simple idea of circular motion. But before we go into simple idea of circular motion, I would like to make a little correction on the last question I just solved. The acceleration there is meter per second squared, not meter per second. The acceleration, the unit of acceleration is meter per second squared, not meter per second. Just make that correction on your question, although it does not affect the answer, the solution. So now, what is simple idea of circular motion? Simple idea of circular motion is when a body is moving around a fixed point. Like a body, let's say this is a fixed point. Now a body is moving around this fixed point at uniform speed. Now, when this body is moving around this point, the speed might be uniform, but the velocity differs. Why? Because the direction of motion is changing as the body is moving around this point. And what is the direction of motion? The direction of motion is the direction of the tangent at that point. What do I mean? This is the tangent at this point. This is the direction of motion. This is V. The direction of motion is eastward. Here, this is a tangent at this point. At this point, the direction of motion V is north. Now, at this point, this is a tangent at this point. The direction of motion is west, while at this point, the direction of motion is south. So that the velocity changes because the direction of motion changes at each one, but the speed remains constant. Now, what keeps this body moving around this circular path without falling off is the centripetal force. The centripetal force is a force that keeps a body moving around a circular path without falling off. And the centripetal force is always acting towards the center of the circle. So this is centripetal force F. This is centripetal force. It always acts towards the center of this circle, and this is F. That's the centripetal force. Now, the opposite of centripetal force is the centrifugal force. The opposite of centripetal force is centrifugal force. If the centripetal force keeps a body moving around a circle without falling off, it means the centrifugal force takes the body out of the center of the circle, as it tends to push the body away from the center of the circle. Now, that is it. Now, from here now, this is a circle. Now, what is the circumference of this circle? The circumference of this circle, C, is 2 pi r. That's the circumference of this circle, is 2 pi r. Now, there are some terminologies you need to know when it comes to simple idea of circular motion. Now, the first terminology is the time period. What is the time period? The time period is the time it takes for the body to move around the circle to make one complete revolution, and that time period is measured in seconds. So T is the time period and is measured in seconds. Now, what are you supposed to note again? What I'm supposed to note again is what we call the frequency. What is the frequency? The frequency is a number of complete revolutions that this body can make within 1 second. And what is the formula for frequency? If the frequency is given as 1 over t and it is measured in hertz, let me call this equation 1. Now, today I'm just wanting to give you a brief summary of circular motion so that when we are going deep into it, you know what we are actually talking about. Now, let's go. Now, we have the angular velocity. The angular velocity is given as 2 pi over t. Now, note that 1 over t is f, so you can also write it as 2 pi f. Let me call this equation 2. Now, also, what do you talk about? We talk about the velocity, that is the speed with which the body is moving around that circular part, and the velocity is given as the distance or displacement over time. And now the circumference of the circle is 2 pi r, which is the distance around the circle is 2 pi r, and the time is t. So it means that the velocity is 2 pi r over t. 2 pi r over t. Now, 2 pi over t is w. So you can also say that the velocity is what? wr, and let's call it equation 3. Okay, now the acceleration of the body moving down the circle, the centripetal acceleration, is acceleration of the body moving around that circle. It's called the centripetal acceleration, and it's measured in meter per second squared. Now, the centripetal acceleration is given as v squared over r. Now, if you want to include angular velocity in centripetal acceleration, this is actual velocity. If you want to include angular velocity, how do you do it? You know that the angular velocity is 2 pi over t. So from here, you know that this is 2 pi r over t. Velocity here is 2 pi r over t. So you have that 2 pi r over t times 2 pi r, which is this square. This is velocity square. This is this square. 2 pi r over t divided by r. Then from here you can see that this is 2 pi over t, this is 2 pi over t, which is angular velocity, which is w. So you have that A is equals to w squared r squared over r, and that will give you A should be w squared r, which is what? Equation 4. So now that is it. So now what else are you supposed to note when it comes to uniform and circular motion? Simple idea of circular motion. What I'm supposed to note again is the centripetal force. Now, force is given as mass times acceleration, which we already know. Acceleration. Now, when you are now finding the centripetal force, you substitute the acceleration to be centripetal acceleration, and the centripetal acceleration from what you have seen here is v squared over r. So the centripetal force can be given as F equals to mv squared over r. When you substitute it to the centripetal acceleration, which is v squared over r, you get this, and let's call this equation 5. So these are some of the fundamental things you need to note when it comes to circular motion. Note from these equations, the w here is the angular velocity, the v here is the actual velocity, while the a is the centripetal acceleration, the arrow is the radius of the circle, then and the m here is the mass of the body moving around the circle. So those are the most of the fundamental things you need to know when it comes to uniform simple idea of circular motion. Don't forget, next time when we are about to do the part that contains circular motion in motion, we divided motion into part 1, part 2, part 3, part 4. There is a part that contains circular motion. So we are going to solve some questions on circular motion so that to give you a better idea on circular motion. You don't want to miss it. Don't forget to subscribe to our YouTube channel, Easy Learning with Sai. Click the like button on our Facebook page, Easy Learning with Sai, and also drop your questions and comments on the comment box below. Drop your contributions also. Thank you for watching. Don't forget, stay home, stay safe. I remain Sai Moses. Thanks for watching.